Good evening, guys, girls. Welcome to Just Eat. We've got the London JS meetup. Welcome. We've got a revered speaker, Kyle, here. And just a few little things to mention. Most of you have found the pizza. Most of you have found the beer. Cheers. In an emergency, we don't use the lifts. There are stairs round by the toilets. So we would lead you out that way. There are signs up there at the back that show you where the toilets are. In the event of an emergency, oxygen masks will... That's the extent of the comedy tonight. So all that remains to say is enjoy the evening, and I'll hand you over to London Jets.
So welcome from us as well. So first of all, thanks for Just Eat for hosting another time, but in a new office, actually. Are we the first one?
You're the first JS.
All right, okay, that's good. The usual format, I think that the talk will take around like a little less than an hour. At the end of it, you will be free to ask any question to Kyle. Just one thing, wait for me to come to you with this so we can record your question and his answer. The reason is we are streaming live and you will be able to see the recording if you're interested. So that's it for me. Kyle, when you want.
Thank you. Well, good evening, and thanks very much for having me here. I take it we're already recording, so should be good. All right. So as you can see, I've only got 255 slides, so this should be a real brief talk. I'm kidding. But you are probably wondering what it is you're looking at here. And so I want to kind of explain. There are no slides yet, but we're going to make those slides together as we talk through tonight. So by way of introduction, my name's Kyle Simpson. A lot of people know me online as Getify, and I've included here my email address because I leave it open for people to provide feedback, ask questions, that sort of thing. What I do for a living is teach JavaScript, so I travel all over the world teaching. I'm actually here in London, having done the last 3 days a private corporate training workshop. So if your company is interested in having someone come teach about JavaScript, please feel free to reach out. I'd love to come and help with that. A lot of people know me from having written a series of books. The books are called You Don't Know JS, and they can be read for free online at this GitHub repo. But you can also purchase the books, which I always appreciate if you've liked them. You can purchase them through O'Reilly or through Amazon or any of those other places. So I encourage you to check out those. I started out intending to write 2 or 3 small, like 50-page books where I shared some notes about some things that I knew about JavaScript from my trainings. And what ended up happening was 6 books and a total of 1,100 pages. So it turns out there's a lot more to say about JavaScript than I realized. But I'm thrilled that it's been so well received by so many people. I thought maybe I'll sell a couple thousand copies when I wrote this, and I've sold over 80,000 copies. So these books have made a bigger impact on the JavaScript community than I ever could have imagined, and I'm thrilled for that. So if I can help in any other way with your journey of learning JavaScript, please let me know. So tonight, we're going to talk about the economy of keystrokes, and I deliberately left it a bit vague to kind of pique your interest. I'll describe what I mean by that. I was sitting around thinking about how to frame a discussion, something that I'm deeply passionate about, almost at a religious level. Like, I'm deeply passionate about this, and it's become an overarching theme in everything that I write and teach about. And this talk kind of sprung from those thoughts. It's an unusual take on what we're looking at. You'll notice that as I'm going along is how we're creating the slides. So it's a new presentation every time. I want to start out with a quote to help frame our discussion. This is a quote from Shakespeare. All the world's a stage, and all the men and women merely players. They have their exits and their entrances. Now, this particular quote has some emotional attachment to me. About a year and a half ago, I retired from being on the conference circuit, having spoken at over 100 events over a period of 7 years and a lot of travel. And I retired from that mostly because I wanted to make room for other voices to be part of it. And so I saw kind of an exit and an entrance evolution happen in my own life and in my own career. So there's deeper meaning there, but at a higher level, I want to talk about Shakespeare, and I want to talk about his process of communication through the written word. You see, because there's a beautiful poetry to what Shakespeare was getting across. And I like to imagine that he was very, very careful about each particular word choice, that he didn't make any sort of accidental choices of words, and in particular even things like where to put a comma or a colon or something like that. Like, he was very specific. He was a master craftsman at what he had to say. And I wondered at one point as I was preparing for this talk, because clearly this is well written out. We see all of the capitalization and the characters and the punctuation that's here. But I wondered if Shakespeare would have felt similar to how we seem to feel today, which is that there might be seen almost an unnecessary amount of information here, that maybe this could be shortened in some way and still get across the same message. So if we were to just remove what we consider all the unnecessary stuff, get rid of all that punctuation, most of the vowels unless they're at the beginning of a word, do we get across the same message? And I wondered if Shakespeare were here today, could I say to him, "Excuse me, Mr. Shakespeare, I know that you're a world-renowned famous poet and writer, but I would like to do a pull request against this play and suggest that this is a more efficient way of getting across your message." How do we think that Shakespeare might interpret that particular assertion, that just because I removed what seemed to be all the unnecessary stuff, are we still getting across the same message? Would Shakespeare say, well, absolutely, I want to be as efficient as possible about communicating my ideas? Now, that's obviously a deliberately hyperbolic kind of a question, but we do sort of take that as developers these days. We do sort of have this bent towards saying the shortest and quickest path that I can possibly dream up is the correct path, because we think that the only important thing is how quickly we can get from I'm starting something to when I've shipped it. And we miss out, I think, along the way, a lot of nuance that's very important. And so tonight's talk is to sort of take a step back and think about some of that. This is not a technical talk. There will be a couple of little tiny snippets of code, but don't worry, if you're not even a programmer, you don't have to be a programmer to understand this. This is not a technical talk. It's rather more of a philosophical talk. So, what we're going to talk about tonight is the economy. And I want to talk about what an economy means, because there's a lot of things that go into the economy. For example, in an economy, you have to be able to trade something of value, which we oftentimes would refer to as currency, or maybe more appropriately, we'd refer to that as money. That's the thing of value that we trade within an economy. And in addition to money in an economy, what we're doing, the primary actions are that we are buying and selling things, whether that is time, whether it is goods, we are buying and selling things with that money. So we have to attach some intrinsic inherent value to something and then decide that I want to buy it. In a traditionally capitalist society, they say that the value of something is directly associated with how much people are willing to pay for it. You can put a price tag on it, but if nobody buys it at that price, it's not worth that. It's only worth what somebody's willing to buy, what somebody's willing to pay for it. So the process of selling something within an economy requires there to be an agreement of value. So these are things that I just want you to think about as we're going through tonight. And in addition to buying and selling, there's another level of this, which is saving and investing. Because we save money, and sometimes we take that money and invest it somewhere else because we're thinking that we will get some kind of return back at a later time. So those are other things that we do with our money, and all of these things go into making an economy work. As a matter of fact, there are macro level forces like inflation and deflation, which will change the value of things. Out from underneath this, I have a dollar bill in my pocket, and that dollar bill will either stretch further or less according to these larger level things that are changing that value proposition. So an economy is actually quite a complex set of things that go into play. And lastly, within the space that I have up there a number that's turned red, I wonder what's going to happen when I talk about one of the other things in terms of not the macro level economy, but in our personal economy, the way we guide ourselves into deciding how much we have to spend and whether we need to save or invest more or make more money is we develop a personal budget. And I seem to have run out of keystrokes, and that's okay, because just like you can cheat on a budget, you can also cheat on the number of keystrokes. So I'm just going to give myself more of a budget. But all of these things are forces that come into play in terms of our decision of how we spend the money, how we spend the thing of value, and what we perceive that value is that we're getting out of it. So I want to turn our attention then to an economy specifically within the realm of what we do in software development. Not the money that we buy and sell in a store, but the kinds of things that we trade for and buy and sell as we are going through the process of writing code. In particular, I want to talk about the keystrokes that we may be spending on something or saving on something or investing on something, that the keystrokes are sort of like our thing of value, that we are using keystrokes to then buy and trade and sell other sorts of things. So what are some things that we buy and sell with the keystrokes that we use within our code? Well, one of the most obvious ones is functionality. When we choose to expend a set of keystrokes in our code, we implement some feature like making the button clickable and making it blue. We expend some keystrokes and we get some functionality. As a result, that's the most obvious one, but I think there's a more important one than that. And the more important thing that we might buy and sell or trade of value within this economy in our coding is the notion of readability. And that's really what we're going to talk about tonight. Is when we spend and save and invest these keystrokes, and when macro level forces of inflation and deflation change the relative value of our keystrokes, how does that impact the readability of our code? I want to try to illustrate a little bit about what I mean in readability. You have probably seen before, if you've written any code, something like this in JavaScript. This is the tried and true JavaScript function. And you'll notice that it takes some input and it computes a value and it gets it back and it assigns it to X. So we are communicating something by writing this code. We're communicating that we want a function that will take a number and double it and return it back and assign it to X. But for many years now, we've had complaints that JavaScript is a poorly designed language and that it's so verbose. And to hear some people describe it, the reason why JavaScript has always been a second-class citizen compared to other more modern and graceful languages is that we spend all of our time writing out the word function and writing out the entire word return, these entirely unnecessary vagaries of our coding. And so we would like to be able to express the same idea in a much more terse way. And so comes in, over the last couple of years, what some people think is the single-handed savior of all of JavaScript, the arrow function. The arrow function is just so much more readable, right? Because we got rid of all that unnecessary noise, that function keyword, all of those terrible curly braces, those god-awful semicolons, all of it's gone. And what we're left with is just such a graceful expression of our idea, right? Because to hear many people suggest, the arrow function is objectively, without any question or debate, more readable than the long-form function version. And you might kind of guess by my tone that I don't really agree with that. And let me prove it to you, because I bet 99% of you didn't even realize that that's the wrong arrow function. This is the correct arrow function. But you didn't even realize that because you're just listening to what I have to say. And the point that I'm trying to make is that these are not actually objectively more readable. They're only more readable within a particular context. And yet we make the claim that we should shorten our code, we should remove as many things as we can because we want to write less. And I want to challenge whether or not writing less is actually what we should be spending our time on. There have been research done into the process of determining, is a piece of code readable or not? I was Googling some years ago about this topic of code readability because it's something that I care a lot about. And I, like probably you, had this notion that readability is a highly subjective task. That one person would rate a piece of code readable and another person might say, well, that code is completely nonsense to me. I don't understand it at all. So it's kind of the one man's trash is another man's treasure sort of thing. Like, you can't really say this piece of code is objectively readable. But I was researching this process, or this concept, this topic of how do we judge readability? And I ran across a paper, and the title of this paper, you can Google it too, you should probably be able to find it. The title of this paper was so ludicrous to me that I quite literally laughed out loud. I know how we all say LOL, and we didn't actually laugh out loud. I literally actually laughed at my computer upon reading the title because it sounded so ludicrous to me. Essentially, the title of this paper was developing an automated metric for code readability. In other words, being able to create some kind of a program, a scoring algorithm that you could pump in any arbitrary code to this program, and it would spit out a number on some scale that told you relatively to the scale how readable the code is. I thought that was completely bonkers. There's no possible way that you could automate something so objective as to give a score of readability. And I began to read the paper and look into its processes. And to be quite honest with you, if you Google it, you may agree or disagree with different parts. I didn't agree with necessarily with all of the conclusions of the paper, but I found the process that they tested it to be quite fascinating. And what they did to try to figure out readability was they brought various different people in, and they would show them different amounts of code. Like, they'd show them 1 line of code, and then 3 lines of code, and 5 lines, and 10 lines. And they'd show them in all different languages and all different things to try to eliminate people saying, oh, well, that's just my favorite language or not. But they showed them all these different things, and they tried to figure out what was it that led somebody, what was the common thread that led somebody to rate something as readable versus not, or what were the contributing factors. And what I found to be fascinating, and I was surprised at first when I read it, that they suggested that from that research, the most important factor, the most overriding factor of all the other ones that they discovered was familiarity. That if a person had seen a piece of code before, they rated it as more readable, regardless of what idioms or syntax or language was used, than if they hadn't seen it before. At first, I was surprised by that, and then as I thought about it more, I thought, shouldn't that have been self-obvious to me? Wouldn't you agree that if you've seen a piece of code a bunch of times, you feel like it's more easy for you to read and understand than if it's the first time that you've seen it? So I thought that was interesting, and when we compare that to the sorts of assertions that people make about readability, like, for example, in JavaScript, the arrow function is so much more readable because I have to type less, that doesn't exactly square up with what the research says people use to determine readability. They don't just say, well, the fewer number of characters is what's important. They say it's what's more familiar. Now, the arrow function is based upon, essentially, mathematic notation. That's where the idea comes from. So raise your hand if you have a degree in theoretical mathematical notation. Anybody? I got a couple in the crowd. For you, I'm sure the arrow function is perfectly readable. But let's take note that in a room of approximately 70, 80 people, I got 2 hands up. So is it true that if you roll out mathematic notation by way of code, that we will objectively see that everybody who reads it will be immediately familiar with that code? I'm not convinced that that argument can be made. That doesn't mean that arrow functions have no benefit and no value whatsoever, but we have to take a step back and more critically analyze this than just jump on the hype train because, oh, I'm tired of typing out this keyword. All right, so familiarity, that's an important thing. Now, as a teacher, that's what I do for a living. As a teacher, there's something I'm really really keen to keeping my eye on whenever I'm expressing or teaching a set of ideas with people. And that's this idea of cognitive load theory. I don't know if you've ever heard of cognitive load theory before. The cognitive load theory is interesting because it describes, probably quite self-explanatory, it describes the idea that our brains can only handle so much at any given time, so much new information, and that it is quite easy, if you are a teacher, to overwhelm people by giving them too much information that they can't really process and lay out into some, and then they just sort of, they get overloaded and they stop learning. That's the obvious part of cognitive load theory, but there's a less obvious and yet more important part of cognitive load theory, which actually, it talks about different kinds of things that we learn, because really our brains will retain different kinds of information differently. So there's different categories of what you can teach people. But one of the things that I found interesting about cognitive load theory is that when you overload somebody, when you give them so much information that they get all full and they say, I'm done, I've got no more capacity in my brain. That's not a conscious decision. Usually by the time somebody's saying, my brain hurts and I'm done, they're well past the point where they were actually full on cognitive load. So it's not even a conscious decision, but at some point when somebody's fully saturated with the information that they can handle, when you begin to give them more information, it is not just the case that they miss out. It's not just the case that they're in one ear and out the other, not listening to you. It is the case that when you continue to pour on more information, it has a subtractive effect on the information that they already learned. That their brain begins to literally start to expel things because of the overload, and they begin to just start forgetting stuff, spontaneously, that they otherwise would have held on to if you didn't overload them. You can probably tell why, as a teacher, that's an important thing for me to be aware of and be careful of, and I take that very seriously. But as that applies to code, I would say that we are teaching people ideas, we are expressing ideas in our code, and if we overload the reader of our code, it should not be surprising at all that at some point code becomes unreadable. There's only so much information the reader of our code can get into their head. And one of the things that contributes to that extra amount of information that we're requiring of the person is that there's a set of information and assumptions that guide our decision-making in our code. There's a set of things that we know as a team, this is how we always do it. So we just write that code, and everybody else on the team already knows that same thing, so I don't need to worry about it. And that works great when the only consumers of your code are people that already have that tribal knowledge. What I'm referring to is the set of unspoken assumptions that go into the decision making that lets you choose how you organize and write your code. It's sort of like tribal knowledge. It's a shared thing that every member of the team knows, and it works great when everybody in the tribe is working on the code. But when you invite a new person into the tribe, they don't start out with that tribal knowledge, do they? How many of you, and this is just rhetorical, but how many of you have showed up on the first day of a job and essentially what they said was, okay, go spend the next week or two just reading our code, right? It happens pretty commonly, right? No matter where I go in the world, I ask that question, I get the same response. People are like, yeah, that's kind of how we onboard people. You know what they're saying without saying it is, hey, we've got a whole bunch of tribal knowledge that you need to know, and it's your responsibility to go figure it out from reading our code. Because we don't want to tell you all the tribal knowledge. We don't even know what it is we assume. We just assume it. That's part of the cognitive load that is coming on a person when they read your code. Do they share the same tribal knowledge that you have? So when you can choose to write code using a more broad set of tribal knowledge that somebody not on your team would be more likely to have, you run the chance of less risk that that person is going to be overloaded when they show up on your team the first day and have to read your code. So it's important that we think about more carefully what types of things, not just that we're writing, but that we're thinking about when we write. Because that goes into how readable, how understandable our code is. So getting back to that earlier question, I said, we buy and sell functionality, we buy and sell readability, but really ultimately what we're buying and selling with our keystrokes in this economy is ideas. We are, in a big sense, communicating ideas with our code. As a matter of fact, I would suggest to you that the primary purpose of your code is not to instruct the computer, but rather to communicate ideas. You might have thought that your job as a software developer was to instruct the computer. I have news for you. That's a far distant second in terms of importance. Let me try to help prove that to you, if I can. Let me make a couple of assertions. The first one is this. Computer science theory tells us that within the space of correctly functioning programs, I don't mean all programs, but just correctly functioning programs, and even within that space, the language or languages that you're choosing to write in. So just within that space, that there are an infinite number of choices that you could make of how to write the code that will produce the exact same sequence of ones and zeros to instruct the computer. There's an infinite number of choices. That's a lot. So with an infinite number of choices, what could we possibly use as a metric or a guide to decide which one we ought to choose? Is it okay to just randomly have any one of those infinite options, or is there some guiding principle that should direct us towards choosing which is the most appropriate way to express these ideas in code? That's the first observation. The second observation is this. As soon as we started inventing computer programming languages, which was way back, as soon as we started inventing languages on top of the ones and zeros, when we moved from the punch card to, say, for example, writing assembly code. Assembly code was the first time we introduced an abstraction between what we write and what actually executes. It's a pretty thin abstraction because the assembly language operations are pretty close to the bare metal, but they're not exactly the same thing as the ones and zeros that the computer processes. So as soon as we started creating these layers of abstraction, and then we went from assembly to the C generation of languages, which is the second generation computer language, and then from C generation languages to third generation languages, higher level languages, scripting languages like the JavaScripts and Pythons of the world. And then we're branching even into fourth generation languages with things like SQL and other natural language sorts of programs. But the more we keep adding on, the more we keep inventing these generations of computer languages, the more we separate what code we write from what instructions actually execute. I'm willing to bet many of you think of yourselves as highly skilled craftsmen and craftswomen in your trade, and you take very seriously the code that you write. You choose very specifically how you write a thing. And when you choose ++i instead of I++, in your mind, there's a reason for that. You have an intuition about what's going on inside of the computer, and you're specifically saying, no, computer, this is what I want you to do. Don't do that, do this. You're trying to precisely instruct the computer on what to do. And for example, when you write a for loop, that's beautifully constructed, and you decide to decrement with -i or whatever, the more we have created abstraction, the more we've created a separation where the computer looks at that code and says, thanks very much for the suggestion, but I'm going to do it an entirely different way. I appreciate you suggesting that I use a loop, but there's a much more efficient way to do it. So really, the honest truth is that the code we write is nothing more than a mere set of suggestions to the computer for what the outcome should be. And it's only getting more so that way. It looks at our code and it says, that's a constraint on my solution, but I have lots of different options to choose from, and I'm going to pick one that's much better than what you, the programmer, came up with. And I don't know about you, but I'm actually glad that the computer is pretty good at that, because if my career rested upon my ability to write highly optimized code, I would not still have a career. I'm glad that the computer is better at that than me. And that really speaks to something deeper that I'm getting at here, which is we obsess about the stuff that we're not good at, and we don't pay attention to the stuff that we actually are good at. Some people subscribe to the belief, I'm not one of them, but some people subscribe to the belief that we're headed towards a future where the computer is going to program itself, the coming AI age, and that software developers themselves are going to cease to be a thing. The computer won't need us anymore. The computer will just program itself, and it'll do so way more efficiently than anything that we could imagine. That's a suggestion as to our coming future. And I don't know if people think that's 10 years from now or 100 years from now or somewhere in between, but there are some people that believe that. I do not believe that, but I do believe that we have something to say as to whether or not we have a long and prosperous future as an industry, or whether we're going to become rather irrelevant. And I think if we continue to obsess about the thing that we're not good at, which is figuring out the most hyper-optimal way to do some micro-level operation like incrementing a variable, if that's what we spend our collective brain power on, then yeah, eventually we're going to become irrelevant. Because the computer is going to get a lot better than that. It's already better than us, and it's only going to get better. But there is one thing that we can do in our code that I think, and I'm going out on a limb here, I fully realize that when I make an absolute statement like this, it's way out on a limb. But I think there's one thing that we will always be better at than the computer. That the computer will never be better than us at communicating with other human beings. And so what I'm getting at here is that the primary purpose of our code is communication with other human beings. And that if we were to focus more on that, we would focus on what we have a strength in and let the computer do the stuff that it's good at. If we did that, I think our jobs and our lives would be a whole lot easier. So, I'm about to bring up somebody who I fully realize is a divisive figure within the overall computing science industry. And I apologize in advance if this person is offensive to you. I'm only invoking them for one particular reason. This guy is quite an asshole, and I hope all of us can kind of agree that he's not a particularly friendly and endearing person, at least in the way he conducts himself online. And this is a very telling picture, I think. Okay? If you don't know who this is, Linus Torvalds, the creator of Linux and so forth. So he's not somebody that I think most people would list on their high on their list of people that are friendly to communicate with online. But every once in a while, even real assholes come up with really intelligent things to say. And he had one recently, and I say recently, it was within the last year or two. I happened upon this thread somewhere in some deep Linux user thread. I happened upon a thread where he was doing a code review or discussing a code review of something that somebody had submitted to the kernel code base or something like that. And he was disgusted by the code that they were trying to submit. Not that it didn't work, but he was disgusted by the style of the code that they had decided to submit. And he said this, he said, "The code could easily have been done with just a single and understandable conditional, and the compiler would have generated better code, and the code would look better and more understandable." For somebody who carries himself as rather much of an asshole, that's a very level-headed and moderated statement, I think, to make. And I think it deserves deeper thought. Let me suggest to Linus that he would have been more efficient had he written it this way. Would have gotten the point across a lot better. But he goes on to say, I want to make it clear to everybody that code like this is completely unacceptable. Isn't that interesting? Because somebody who we would normally think is all about make it as hyper fast and efficient as possible. And what was his concern? His concern was it is unacceptable that somebody would try to put their own cleverness above the greater needs of code being readable and understandable. Another way of putting it, as Martin Fowler did, is any fool can write code that a computer can understand, but good programmers write code that humans can understand. You see, because the primary purpose of our code is for other humans to understand it. So when you focus on, no, I've got to write code that's super optimal, hyper, 1 millisecond, microsecond faster than it was before, you're focusing on the thing you're not good at, and you're missing the thing that you are most good at, communication. Within the HTML web platform, there's a spec that drives the web platform. And there's an interesting part of that spec which many people have not read, and I find it strange that us as practitioners of the web, we don't really tend to spend much time reading our own founding guiding documents very often. When I ask a room of JavaScript developers this size, how many of you have read any part of the spec, I usually get 2 or 3, maybe 4 hands. And I ask people, have you read any part of the HTML spec that you make a living building? And most of them say, no, I don't need to read the spec. It's interesting to me that we take this seriously, but maybe not seriously enough. But there's a part at the beginning of the HTML web spec. It's called the principle of constituencies. And, I'm sorry, the priority of constituencies. So the priority of constituencies basically says this: wherever there is a conflict in priority, that is, if we have different constituencies that are pulling us to do something one way versus another, wherever there is a difference in the priority, consider the user greater than the author greater than, and it goes on to suggest a whole list of priority constituencies that may have concerns over how to build the web. But you'll notice the important part is that they put at the very top of the list the user. They suggest that the guiding principle upon which we should build the web is that wherever possible, when there is a conflict where authors want something that's good for them, but maybe it's bad for users, no, don't do that. The user is most important. I can think of a whole bunch of places where we haven't followed that guiding principle, where we place our own abilities to be developers and do things hyper efficiently, and it's only a far second cry that we think about how's that going to impact the user. Let me be so bold as to suggest a priority of constituencies, but not for the greater web. Let me just focus on, for us software developers, writing code, writing and reading code. Let me suggest that that priority of constituencies should be that wherever there is a difference in priority, wherever there's a conflict, we should consider the reader as more important than the writer of the code. You probably spend a lot of time at your work, and you think that you spend a lot of time at your work writing code. You probably feel like that's your primary job responsibility, is to write code. Maybe some of you are unfortunate enough to have a secondary job, which is sitting in meetings. But most of you probably spend a lot of your day writing code. And you think that's where I spend most of my time, so therefore I should optimize that part of my job. And there's no end to the amount of things that we go to, the hoops that we jump through to optimize how we write code. We invent new frameworks and new libraries every day. There's probably somebody in here right now that is currently inventing the next big framework that'll take over. We spend a lot of time optimizing the writing. That research I was talking about earlier, that was talking about readability, they cited another paper, which I also went and read, and I found fascinating. They cited a paper that asked the question, what do developers spend their time on? And I found it interesting and intriguing that when they studied software developers, they found that software developers spent as much as 70% of their day not writing code, but reading code. 70% of your time is not spent doing the thing that you spend 90% of your time optimizing. You spend 7 hours a day figuring out where to put those 5 lines of code. Because did you know that the global average for lines of code written by a developer per day is 5 lines of code? So you spend 70% of your day figuring out where those 5 lines go. Now, those researchers suggested that because we're spending so much time reading code, that we should spend more time optimizing the code for readability. Does that sound like such a crazy premise? Some of you may be thinking to yourselves, well, that sounds all well and good. He wants me to spend more time on readability. They actually went so far as to say there should be a whole phase of the software development lifecycle dedicated to readability. And I agree with them completely. But some of you may be thinking, well, that's all well and good from an Ivy Tower, but my boss would never let me do that because we got to ship. We got to get code out the door as quickly as possible. And they use every metaphor under the sun, like we're a race car and we got to change the tires while we're driving. And I've heard every one of the metaphors because I've worked at every startup under the sun. I know what they say. We got to go fast. We don't have time for stuff. And that's the same argument they make of why you don't have time to write tests. And it's the same argument used for why you don't have time to write documentation. Same argument applies here. I don't have time to make code readable. I just got to make it work. Different, I think, even than tests and documentation, however, is the assertion that you don't have time to make code readable is a myopic, narrow-minded that misses not even a big picture, just a slightly bigger picture. Because the code that you write today, those 5 lines of code that you're going to write so well today, those 5 lines of code are going to be read tomorrow, and the next day, and the next day, and the next day. When you don't spend any time optimizing how that code is going to be read, you are going to cost yourself a lot more time tomorrow and the next day and the next day and the next week and the next month. And it's not just you, it's other members of your team that are going to see that code. You sometimes think that you write in a vacuum. You write code and then you almost never need to touch it again. But the reality is that a piece of code gets written once and read hundreds of times. So it adds up pretty quick. If that code that works, that you wrote really quick and felt good about, and you got the feature shipped, but it's really poor to understand. So when you think to yourself, my boss would never let me take the time to spend on readability, when you say, I don't have time to write readable code, I suggest to you that you're thinking about it wrong, and you don't have time not to write readable code. Because tomorrow and the next day and the next day, you're going to bog yourself down with all that code. And eventually, at some point, you're going to have this conversation, because I know you've all either had it or heard this conversation. Eventually, at some point, somebody's just going to say, you know, I've been trying to implement this thing, but it would just be quicker if I rewrote it. Anybody ever heard that before? Or have you said those words before? Have you ever wondered why we do that so often? Maybe it's because whoever wrote that code, whether it was us or not, didn't really think about the readability. Didn't think that somebody was going to have to read this code many, many times to figure out what it was doing. Maybe we optimized for the writer instead of for the reader. So these keystrokes that we're spending. One of the things that we like to admit that we buy with our keystrokes is convenience. There is no end to the amount of tooling that we will create to try to save ourselves one keystroke. We will create entire ecosystems just so that we have one fewer keystroke on the command line. And I'm not even exaggerating things. This is what we do because we feel like I'm going to do this on the command line so many times, it's worth the investment of my time to create this whole ecosystem of stuff. And one of our favorite tools for convenience is the convention. We say, well, we don't need to document how stuff is done. Everybody on our team knows that if you put the file in this particular location and it's named exactly this way with a capital letter, that it'll just automatically get served up to the web server. And it always has worked, no problems whatsoever. And everybody knows it, so there's no reason to document it. There's no reason to test it. It's a good convention, and it saves us time. Until a new person joins the team. And the new person says, well, how do I get my file up on the web server? And you go through this song and dance of, well, okay, you got to put it in this location and make sure it's a capital letter and make sure it's got a number in it, but not too big of a number and all of this stuff. And it's just a black box. You're like, okay, great. And they put the file there and it works. And then the next person does that and the next person. And you know, when it's on the happy path, convention is great. But I don't know about you, I've certainly had plenty of times where I went off the happy path. And as soon as you get off the happy path, convention is the absolute evil because nobody has any idea how all of these conventions interoperate. It's been one nice big house of cards that's just been working, but as soon as I put a file in that location and I name it correctly and I put a number in there and it doesn't get served up, how do we fix this? Nobody knows. It's always worked. The guy who made that convention moved on to the job, a different job 10 years ago. Nobody has any idea how files actually get served, but boy, we've sure been optimal at putting files there when we were on the happy path. And we didn't stop to think, how will somebody later who doesn't know the system fix it when it breaks? Not if it breaks, when it breaks. How will they fix it? Fixing convention-based systems is not as easy as we would hope. There's a talk that I think more people should see than have seen. As a matter of fact, I would make this talk required mandatory watching for every developer, and not just once in your career, like maybe once every 6 months or so. You should watch this talk, and if you have not seen it, go Google the talk Simplicity Matters by Rich Hickey. The earlier version of this talk, this was the second version, the earlier version of the talk, which is also great, is called Simple Made Easy. The premise of this talk, I will not reiterate the talk because Rich does it much better than I do, and I recommend you go and watch it. But the premise of this talk is essentially that there's a difference between simple and easy. And he goes about that difference between those two by actually looking at their opposites, which are complex and hard. The word complex comes to us from the Latin root of the word complect. And complect comes to us from the idea of taking strands of rope and tightly weaving them together to make a rope that is really, really strong. But you'll notice something about those strands of rope, they are really tightly coupled together. So if you're looking for the best visualization that I could possibly imagine for what complex code is, it's code that's tightly coupled together. And the opposite of tight coupling, the opposite of complected code, is code that is loosely coupled, where these pieces are individually addressable. We can look at them and reason about them and take them out and replace them if we need to. And he talks about the idea that if you focus, your primary task is, I want to make things easy, then you will almost never arrive at a simple system. You will almost always arrive at a complex system. Here's my one of many that I could share, examples of going after easy and arriving at complex. Node.js. I love Node.js. It's a fantastic system. A couple of years ago, I had this really weird situation where I needed to install Node on this really old virtual machine that I could not upgrade because it wasn't even a supported version of Debian anymore or something like that. And I just had to install Node on that VM. Sorry, it sucks, but that was my reality. So I went to install Node, and I got an installer error. And the installer error that I got was that my version of Python on that system was not up to date. Now, I was trying to install Node.js, and I was getting a Python error. Just let that sink in for a moment. I didn't even know I had Python in the system. I guess it ships by default with Debian. But they were telling me that whatever Python version I had was not up to snuff. So I was like, okay, cool. I wanted to install Node. Now I got to go figure out how to install Python and configure it. But okay, I'll go try to figure out if there's some kind of package for this Python thing. And I went down this rabbit hole 12 hours later, finally realized that the Python that I needed wouldn't install on that system because my glibc wasn't correct or some other ridiculous bullshit. So all I wanted was Node, but I had to get Python, and I couldn't get Python because I couldn't upgrade glibc, and on and on and on, and I'll spare you the gory details. But what it boiled down to when I complained to the Node system, to the Node folks, and I said, why do I need Python to install Node? And they said, oh, well, because it was easier to write cross-platform installation instructions in Python than it would be to do it in something that works on every platform on the planet, like Makefiles. No. Let's not do Makefiles. Let's use Python, because it's easier to write cross-platform installation. Now, in retrospect, I was a lot more harsh in my my responses to them than I should have been. Because I get it. Systems are hard to manage. Architectures are hard to manage. But it's a perfect example of it's easy. But when you go after easy, you're going to arrive at complex almost every time. When you go after simple, you oftentimes can attain easy. That's the premise of this talk. So I recommend you go and look at it because it leads directly to what I'm talking about the code readability. We put all of this extra effort on, our readers by making them do all of this extra work. Some examples, just real simple. In code, if I type code like this, if I said x plus y times z. Now, that's a very simple JavaScript statement. But do you know which one of those two operations is going to run first? Is it going to do x plus y first and then multiply that by z? Or is it going to do y times z first and then add x into it? Some of you are nodding your heads because you are aware of a particular kind of tribal knowledge called operator precedence. Not all readers of our code know what operator precedence is. But some of them do, and some of them don't. So when you write code that says, I'm just going to do the y times z because I know the operator precedence will run that one first, even though it's on the right-hand side, I know it'll run it first, you are inviting other readers of your code that do not have that tribal knowledge to be confused because they don't know what's going to happen. Now, there's a very simple fix for this, actually. You can put in some completely unnecessary parentheses. And I like to imagine that the JavaScript engine would literally laugh at me for putting in these unnecessary parentheses, because it's going to say, I don't need those things. But why are those parentheses useful? Because they remove the ambiguity. They make it very clear to the reader of this code that y times z will happen first. There's no ambiguity, there's no doubt, there's no me having to go look up on MDN to figure out which one's going to happen. You're telling me very explicitly. So maybe I should spend a couple of extra keystrokes to get some readability. Maybe the most readable code isn't the most terse code. Another example, how many of you have ever written something like this? It's the default value idiom. We use this to default our parameters, at least prior to ES6. Now what you're doing here is you're inviting the reader of your code in on a nice little niche of tribal knowledge, which is that the OR operator in languages like JavaScript, Ruby, and Python doesn't work the same as it works in language like C or C++. In those languages, this operator returns either true or false. It's called a Boolean operator because that's what it does. It decides true or false. But in our languages, it's called a Boolean operator, but it's not going to result necessarily in true or false. Actually, what it's going to do is select one of the two values, either the x or the 42, based upon a truthy check of the x. It's really not a Boolean operator. It's actually a selector operator. We don't do ourselves any favors by calling it stuff that doesn't make any sense compared to what it does. But you're inviting the reader of this code into that particular type of tribal knowledge. And if they know it, great. But if they don't, they're going to have to go Google for it. And they're going to arrive on a Stack Overflow answer that has a 95% chance of being wrong. My favorite is the ternary operator, especially when we string multiple ternary operators together, right? That is the most readable code of all, because we all know that the most readable code is the entire program all on one line, just like we learned in Perl, right? Perl, famously the write-only language. It can be written but not read. Kidding, of course. I wrote Perl, so I get to make that joke. But I love it when we put these ternaries all on one line strung together, because we invite the reader of that code not just into the tribal knowledge of what the ternary operator does, what operator precedence is, but another nice little fun tidbit of information, which is called operator associativity. You might not be aware that operators are either left associative or right associative, which has to do with how operators group themselves when they're at the same level of precedence. And the ternary operator has a different associativity than most other operators do. Most operators are left associative, which is where we get the whole left to right thought process and myth about how code runs, is that most operators are left associative, so they have the effect of operating left to right. But guess what? The ternary operator, it's right associative. So if I write out a nested ternary, You're asking the reader of that code to understand not only operator precedence, but associativity so that they know exactly which clause, excuse me, which clause goes with which operator. As opposed to, you know, just, oh, I've run out of characters again. Those darn budgets. As opposed to just using an if-else. You know, what's so wrong with writing out an if-else? Is it really worth saving just a couple of characters? Now, you might be wondering at this point if I'm suggesting that we should dumb down the code to the dumbest, simplest possible version of itself. I get this a lot. I get people asking, well, does that mean we need to boil it down to the lowest common denominator? And I would push back on that and say, no, I'm not suggesting that we need the dumbest possible code. What I'm suggesting is that we should always be looking for opportunities to have everybody learn. And one of the best ways for everybody to learn collectively is through code review. Some people think of code review as a negative thing because it's used in an abusive way to swat somebody down and prevent somebody from getting something into the code base. But that's not how code review ought to be used. It ought to be used as an opportunity for people to learn. When a more junior person on your team submits a piece of code that functionally works and passes a test case, but leaves something to be desired in terms of readability, you, more senior engineer, could take that opportunity to say, let's sit down for a couple of minutes, and let me say, did you know that you could have done it this way? And that might have communicated more clearly. Now, instantly, both of you just learned something. You learned it a little bit better because you taught it to somebody else, and they learned it better. Took you 5 minutes. We should all be learning, but here's a little heuristic to figure out whether or not learning something is worth it. Because you can, for example, take a for loop and replace it with some cool little bitwise trick. You can come up with like a bitwise operator string that replaces the need to do a for loop and feel really clever about yourself. You're like, man, I'm awesome. And you invite the reader of that code to learn that bitwise trick. Maybe you put a comment there, you probably don't, but maybe you put a comment there that links them to some white paper about bitwise math, and there you have to go learn all that stuff to figure out how clever and intelligent you are for using this trick to avoid a for loop. But the problem is that that learning that they invest will not pay off beyond that line of code. The chances that they'll ever get to use that knowledge on any other line of code are approximately 0. On the other hand, when you ask somebody to learn something very useful and very widespread in use, like for example, many of the things that were added in ES6 that allow us to write more declarative code. One of my favorites is the ... operator, the spread rest operator. When you use something like that, yes, somebody's going to have to learn what that is. When they see it the first time, they're not going to know what it is. But when they go learn it, and when you help them by showing it to them in a code review, or having a brown bag lunch, or any of a dozen other ways that you can transfer knowledge to your peers, when you help them with that, that knowledge and that investment of time will pay off far beyond that line of code. So I do want us all to learn. I'm not concerned with where you are with what you know. I'm concerned with what your direction is. Are you learning more? If you're learning more, great. If you're not, that's the problem. How many of you have ever heard the term abstraction before? Anybody? This is one of our favorite buzzwords to throw around, isn't it? We all love to talk about abstraction because it makes us sound smarter. Well, I abstracted it. And on my abstraction, I abstracted this abstraction to the abstraction so that it's abstracted. And your boss is like, cool. Right? Do you even know what abstraction really means? Because most people, when they say abstraction, what they really think is they think, oh, I'm hiding things. I took this thing that was ugly and I didn't want to see, and I hid it away behind an abstraction. That's not what abstraction's about. Abstraction is actually about separating two highly complected, highly coupled things into two separate things not so that one of them can be hidden away and not thought about, but rather so that both of them can more effectively be thought about independently. And the way you accomplish that is to put a semantic barrier between the two things. The easiest example of that is when you have a piece of code just written there, a bunch of plus and minus operations or whatever. When you take that code and you pull out the how from the what. In other words, that code does something and then you do something else with the result. When you take the how of that computation and you put it over here in a function and you give it a good name like calculate international shipping rate. Good descriptive name. That name becomes the semantic boundary between how we calculate the rate and what we do with the rate. Before, they were highly complected together, and it was much harder to reason about either of those two pieces when they were stuck together. When we separate the two and create a semantic boundary, they become easier to reason about independently. That's an important thing that we should be using in our code to improve code readability, but we don't do that very often, do we? We don't spend that time. That's not how we often spend our time. How many of you have ever heard of Arthur C. Clarke's 3 laws? He was a famous science fiction reader. And in particular, Arthur C. Clarke's 3rd law, which says any sufficiently complex technology is indistinguishable from magic. Anybody heard that before? It's a, often cited, it's a well-cited piece of science fiction knowledge. But I want to go just a little bit further. I'm going to take the artistic liberty and I'm going to paraphrase that law. And I'm going to say many of us developers actually feel that any sufficiently complex code or any sufficiently confusing code is indistinguishable from magic. Let me say it this way. Any sufficiently unlearned code is indistinguishable from magic. Isn't that true? Isn't it true that if you have a piece of your system that you have not taken the time to learn, that code is essentially, because it's unlearned, it's essentially magic? And as soon as you take the time to learn it, guess what stops being magical anymore? That's the dividing line. Whether we took the time to learn it or not is the dividing line between whether it's a magic black box that we might as well just have an incantation and dance around, versus I know exactly what it does and how it works, and I know how to make it do what I need it to do. The difference is whether we learn it. But the barrier to whether we learn it is whether somebody spends the time to make it readable or not. So, keystrokes. Those things that we've been spending in our economy. We've been spending them in what I hope is not too offensive for me to suggest, potentially unwise ways. And my thoughts tonight have been designed to help challenge some of those assumptions that you have about code readability and the importance of code readability, to get you to go back to your team and discuss and debate and wrestle with this topic. I'm not suggesting one right answer to any of the questions that I raised, but rather that those are the questions that you should be asking and haven't been asking. So to wrap up, I would say it this way. My advice to you is to make every keystroke count, including real value. Make every keystroke count. Every keystroke spent and every keystroke saved. If we work on making our code more readable, our code will also be more teachable. And I think that is the way for us to get rich in the economy of keystrokes. So thanks very much.
Thank you. So, time for questions.
I can't imagine that anybody's going to have any thoughts to share after that.
Well, if you have any question, yeah.
It's not so much a question as an observation that you spoke about the code review, and my experience is that code reviews are as much about team power play and politics as coding. Would you agree with that statement?
I do agree that code reviews are often abused. And I think it's a tragic shame, because I think it's one of the most important of, there are many, but it's one of the most important tools that we can use to ensure that everybody's growing.
Yeah, I personally would have used a ternary there.
You would have used a what?
A ternary there.
Oh.
And you go, oh, sorry. Any more questions?
Thank you. Kyle, I know that you are right, or I don't know if you already finished writing the book about functional programming. And I think it relates a little bit there, right? Because parameters always written like just an X or just an Y. And I remember when I first started learning it, to me, it didn't make any sense. Like, why people don't put a meaningful name on this, until you start getting the way that actually it needs to be vague enough so it can fit anywhere. So how do we measure it? Like how do we get the balance between I actually need something that doesn't mean anything so it can fit generally in the code, and having a more descriptive name that can confuse people in the future?
Yeah, that's a really good question. I'll respond first by saying in my Functional-Lite JavaScript book, which is again up on my GitHub repo, at the very beginning of the first chapter, I quote somebody who tweeted. I don't know that I'll get this quote exactly right, but he said, "A functional programmer is somebody who names their parameters X and Y and names their patterns zygohistomorphic prepomorphisms," right? Because we have very descriptive names for our patterns, and then we, in our code, use these very undescriptive variable names and parameter names. So I agree completely that that is a problem that plagues a lot of the functional space. And I personally, as somebody who's been on a journey to learn functional programming, have been trying to balance pragmatically what you read and know about the right way to do functional programming with what I already know about writing readable code. And I don't think that either path that you suggested, writing out a full long descriptive name that's way too over specific and hurts your generalization, or writing the variable name X, I don't think either one of those is always going to be the right answer. So I don't really have a lot of great suggestions, but I would say that if you are stuck where you're like, I want this parameter name to be called list, but here's another place where it's not going to be a list, it's going to be a whatever else, it's going to be a tree. If you can't come up with some other name to describe it, like data structure, that's more general, that covers both cases, then you'd probably need two functions, even if those two functions do exactly the same thing. Describe one function for dealing with lists and one function for dealing with trees. I don't think that just being dry and having one function with one random parameter name like X is going to end up overall being more readable. So that's not a terribly great articulated answer to the question, but my instinct is if I really couldn't come up with a good descriptive name that covered both, I'd write two functions.
Okay, any other question, guys?
Back there.
Okay.
Does function size factor into anything? So we've got the example there. Gentleman spoke about generic functions and using very loose variable names. If your function is a one-liner, right? X. If it's a one-liner that is very easy to parse, what is the issue potentially? A one-liner is loaded, right?
You're saying, why can't I use a one-liner and do an arrow function? Damn it! What's wrong with my arrow functions? Is that your question?
No. I guess I'm saying, if the function is bigger, then I probably need to be more specific with my name. But if the function is pretty small and pretty tight, then does it really matter if the function name is, the argument names, the variable names are descriptive or not? Does that matter?
So in the happy path, no, it doesn't matter. In the happy path, you're going to write that code once. It's going to work that correct way forever and ever, and there'll never be an exception. But in the non-happy path, which is where most of my career has been spent, I'm going to be in a debugger somewhere, and I'm going to be stepping through a bunch of code, and I'm going to be kicking myself for using X and giving that function no name, because in my stack trace it says line 1, character 32,712, which I have no idea what that is, and it's going to call it an anonymous function. And the parameter name that threw the error is going to be called X. And I'm going to have no information whatsoever in that debugging session.
No, that's fair. That's fair.
I'll take it. I think that's the best compliment I've ever gotten. Well, that's fair.
Okay, get ready.
Hello. Where do you draw the line between what you call tribal knowledge and the capabilities of the language? So you use the example of using that operator at that time for defaults, but then you said a few minutes later about the spread operator. Now, what's the difference between Googling the spread operator and then Googling the behavior of another operator in JavaScript, for example? Where do you draw that line?
Yeah, so first off, I would say I'm really using the term tribal knowledge to more refer to the things that you do that are specific to your team, the conventions and the idioms and the styles that you all know and that a new person to the team won't know. So I'm more using tribal to refer to that knowledge rather than the globally available knowledge of Google. Because somebody can't Google what do they mean when they put the file name as capital letters. They can't Google that within your company. They either know it or they're stuck and they have to go seem like an idiot and ask that question of somebody else who does know it. So that's what I more mean by tribal knowledge. But even within the space of non-tribal knowledge, the stuff that's globally available, not all things that are added to JavaScript are equally useful to learn. There are things that pay off that increase readability of code, and there are things that I quite frankly think were added just because somebody thought they were clever. Now, that's not meant to criticize TC39 because I wouldn't want that job. It's very difficult to manage the evolution of a language with so many different constituents. But I don't universally endorse learning everything in JavaScript and using everything. I endorse being aware of all things in the language so that you're not surprised, and then picking and choosing the stuff that will increase the awareness on the team versus the stuff that if you use it just in this one little place, it'll pay off only on that line of code. So the best thing I can say is I look for the opportunity to use a thing that when other people have to learn it, it's going to pay off not just across my code base, but across every other program that they ever write. And if the more I can do that, the more I've contributed overall to all boats rising with the tide. If I use some little quirk of a trick of this operator in this one little corner case because I read the spec and nobody else did, I'm going to feel really good about myself. That person's going to spend a lot of time learning it, and then they're never going to get to use that knowledge anywhere else. Does that help?
Yep.
I think I got the right way. Yeah, I was just wondering, what are your thoughts on the argument that people have for writing frameworks that are supposed to make JavaScript more simple and standardized for people to use?
I first off would not in any way, shape, or form agree with the assertion that frameworks make JavaScript more simple.
I do agree with
they
you. It's just
certainly make
claim.
JavaScript easier. Easier to ramp up on, easier to prototype, easier to get an app and call it production. They certainly do that. So what was the...
I suppose it's because at the beginning of the talk you were talking about the way we should be trying to communicate more. And people often write frameworks. I've seen in the more recent frameworks, people say things like, if you use this framework, your team will be able to communicate better. You'll be less tribal because arguably you're abstracting the tribal principle to someone else who has made a set of rules that you can all adhere to. I don't actually agree with that myself. I was just wondering how you felt about that because this does come up quite often.
Frameworks are good at creating their own sort of DSL within the overall language. And to the extent that you can get a big community around that and a big wave of momentum and support around that, I can certainly agree that somebody within that community is going to be able to more effectively communicate their ideas within that DSL, that purpose-built set of thoughts and processes around that. But I don't necessarily agree that that's going to be a portable skill set, that once you're good at that in the React ecosystem, that means you can take that knowledge and awareness and skill and then go over to the Angular ecosystem. So one of the things that bothers me is that we create a bunch of these walled gardens where all of this knowledge stays with the React ecosystem, and it's not even remotely portable to the Angular ecosystem, for example. I think we should be focusing a lot more on the skills that can bridge the gap. I am glad that frameworks exist. I think a lot of times frameworks are too heavily relied upon. If you go back to kind of the original ideas behind frameworks, they were less about creating this big structure upon which a production app would go to, would ship, and more about helping you rapidly prototype and develop an idea when you were still exploring the domain space. They were about the initial parts of the development. And then as you refined your idea, what you were supposed to do is go take out all the stuff that you weren't going to use, and what you were supposed to be left with was nothing more than what was exactly needed to solve the problem. We somewhere along the way lost track of that and said, no, what we need is a framework that has every possible combination of everything that we could ever imagine, plus a bunch of other stuff that we can't even imagine, just in case somebody ever needs to invoke that part of it. So we rely too heavily upon it as a crutch. When I hear people say, I shipped a React app to production today or an Angular app, to me, what that sounds more like is I shipped my prototype to production. And I didn't take the time to go back and make sure that it was just what was needed and no more. It is true that we've got tools and techniques like code splitting and dead code removal that are sort of patching that gap, but that's still a responsibility of ours, I think, because when you have a giant code base that you are only using 10% of that framework, and then you invite a new person to join your team, how do they know which 10% you're using? They're probably going to spend an awful lot of wasted cycles learning a bunch of stuff that you're not even using. So that's one of the problems that I have with our modern usage of them. I like that they exist, just think we stay too reliant upon them too far into the life cycle.
Would you say that the fact that JavaScript is not a typed language maybe amplifies the issue of code readability?
Do you mean that the dynamic typing system makes code harder to read?
Possibly, yeah.
No, I would not say that at all. I think the fact that JavaScript has a typing system, combined with the fact that everybody's been told that that typing system sucks, combined with the fact that they were also told, don't go learn that thing. There was a book that was written a while back that said, don't go learn that thing. So nobody did. It's amazing when you tell people not to learn a thing, they're like, cool, I'm not going to learn it. So we have an entire set of generations of JavaScript developers that have taken this entire part of the language, which I happen to think is actually really useful, and they just never learned it. And they were furthermore told that it's scary, there be dragons, be careful with that. Don't go near that code. Don't use coercion, for example. They were told that it was poorly designed and it was a bug in the design of the language. Helped along, unfortunately, by the creator of the language also saying, oops, I shouldn't have done it. But there are those of us that did take the time to learn the typing system and actually really do enjoy it. And I do actually think not just that it is something that can be learned and used effectively, I think we're missing out on the opportunity to make more readable code by using those parts of the system responsibly. My example is this. If you are in a statically typed system and you have this type A that needs to get to this type B, but there's multiple intermediate steps that it has to go through, you end up annotating each one of those type step conversions. So your code says, I go from A to A1 to A2 to A3 over to here to B. And that code gives all the gory details. Now the question is, does the reader of the code need to actually care about all those intermediate transitions? Maybe, but maybe not. As a matter of fact, in my experience, because I did write a lot of statically typed code, I wrote a lot of Java and C++ back in the day, and most of the time when I ended up doing all of those type conversions, The only thing that really mattered was the starting type and the ending type, and everything in between I didn't give a shit about. But it was still there cluttering up my code. Using type coercion responsibly allows me to offload those types of details to the engine so it doesn't clutter up my code. So that's one example of how I think we can actually reduce the clutter in our code and make it more readable if we use a system, but you can't use a system until you learn it.
Any other question, guys? Well, then I think that's it. Thank you. Thank you, Kyle.
Thanks very much.
Now, one thing I deliberately didn't mention in the preliminary